Hello students, stability factor represents the rate of change of change of the collector current with respect to the reverse saturation current okay, that is stability factor is represented by S. Then S is equal to rate of change of the collector current with respect to the reverse saturation current. Okay, let us take this as equation number 1. Then we know that what is IC? IC is equal to beta into IB plus 1 plus beta into IC naught. If you don't remember this formula, go back to the previous videos of my channel. Okay, I'll give this in the description here. Then let us take this as equation number 2. Partially differentiate with respect to the IC for equation number 2. Then what we get here? Dou by dou IC of IC is equal to dou by dou IC of beta into IB plus dou by dou IC of 1 plus beta times the IC naught. Okay, what is this value will be? 1. 1 is equal to what we can write here? Beta times dou IB by dou IC plus 1 plus beta into dou IC naught by dou IC. Okay, now what I want to find here, I want to find the value of this value, no? So let me manipulate this 1 minus, let me bring this value to the other side. 1 minus beta into dou IB by dou IC is equal to 1 plus beta into dou IC naught by dou IC. Now what do you mean by stability factor? Stability factor is defined by the rate of change of collector current to the collector current with respect to the reverse saturation current. So this is what the stability factor, right? So I will be manipulating this in this way. Then what I get here, I will be manipulating this. Then stability factor S is equal to dou IC by dou IC naught is equal to 1 plus beta by 1 minus beta times dou IB by dou IC. Okay, this is the stability factor. Okay, for any transistor this dou IB by dou IC lies between 0 and minus 1. So 0 indicates what? If dou IB by dou IC value is 0 means, then stability factor will be, if this value is 0 means, then what we get here? 1 plus beta by 1 minus beta. Then stability factor will be what? This value is 0 means we get 1 plus beta by 1. So stability factor will be what? Maximum. When dou IB by dou IC value will be 0. So if this value is minus 1 means if this value is minus 1 means then stability factor will be what? 1, which is a minimum value. Okay, stability factor, smaller stability factor means smaller the stability factor, larger the collector current. Okay, ideal stability factor should be 1. So in general, ideal stability factor will be what? 1. Okay, as smaller the stability factor is desired, ideal stability factor should be 1. So let us write here the procedure to calculate the stability factor. Okay, let me write here procedure to calculate the stability factor. Procedure to find the stability factor is, step number 1 will be obtain the expression for the first base current. Obtain the IB expression, base current expression first. Expression or equation through KVL in an approximate loop. In whatever the loop approximate loop you apply, so that you can find the value of IB. The next step will be, step number 2 will be find dou by dou IC of IB through differentiation. Okay, the next point will be substitute the value of dou IB by dou IC in S value. What is the value of S? 1 plus beta by 1 minus beta into dou IB by dou IC. Substitute this value in this stability factor. Okay, let us do this by an example here. Okay, for example, a question given like this. This is the resistance B, base resistance, connected to a transistor of NPN, having the collector resistance RC. This is the collector voltage, and this is the emitter resistance RE, connected to what? Ground. And this is the let us consider this is the base voltage. Okay, base voltage connected to this one, and this is the base current. Okay, and this will be the collector current, and this will be the emitter current. And asked to find what? Find stability factor. Find the stability factor is equal to what? That is what? S we have to find. To find S, what is the first step we require to find? First, find the value of IB. Then differentiate that IB with respect to IC, then substitute in the value of S. Okay. Then how do we apply this one? The solution will be using KVL in first loop. Let us take the loop 1. What is the loop 1? You can apply in this loop. Okay, because this is grounded, no? Ground to ground. This loop is closed. Then what we get here? If you apply minus VBB plus IB into RB, yes or no? IB into RB plus what is the voltage appearing here? Plus will be VBE plus what is the current flowing through this part will be? Current flowing through this part will be here IC and IE both are same. IE and IC both are same means we can also take this IC. You have to remember these points. Okay, IC and IE both are same, so I can take here IC. Then the current flowing through this part will be IC plus IB. So IC plus IB into the resistance will be RE equal to 0. Sum of all the voltage drops in a loop is equal to 0. Then IB into RB plus RE is equal to what we can write here? VBB minus VBE minus IC into RE. Okay, hope you understand this point. I have commoned this IB into RE. So the remaining part will be like this. Then we can even manipulate or simplify this equation. Then value of IB will be equal to 1 divided by RB plus RE into VBB minus 1 divided by RB plus RE into VBE minus IC by RB plus RE into RE. So this is the equation number 1. We have obtained the value of IB in terms, this expression is nothing but IB. Now step number 2 will be, what is step number 2? Step number 2 is what? Differentiate the IB value with respect to IC. Then what we get here? IB will be dou by dou IC of this equation number 1. Then what we get here? Okay, IB will be differentiated with respect to IC. Okay, then what we get here with respect to IC means there is no IC term here, there is no IC term here. The only IC term will be present here is, because this will be 0, this will be 0, only this part will be coming here, minus IC by RB plus RE into RE. If you simplify this, what we get here? This part will be a constant out of the differentiation. Then what we get here? Minus RE by RB plus RE. So this value will be what? Dou IB by dou IC value will be this equation. Let us take this as equation number 2. Okay, then what is the step number 3? After finding this dou IB by dou IC, step number 3 will be what? Substitute the value of stabilization factor. 1 plus beta by 1 minus beta into dou IB by dou IC. That implies 1 plus beta will be as it is beta divided by 1 minus beta times, what is dou IB by dou IC? From equation number 2, what we can write here? Minus RE by RB plus RE. Then if you simplify this, what we get here? 1 plus beta by 1 plus beta into RE by RB plus RE is the stabilization factor. Hope you understand this point.